So the closest power line to the parking lot runs along a straight line that contains those 2 points. At what point should the power line be connected? So back to the first example, this is where the light is. We need to figure out the shortest distance from this point to this line. Anyone remember what type of line you would draw to calculate the shortest distance between a line and a point? Perpendicular line. Remember we talked about this? If I draw a line like this, that's a lot longer than a line that runs perpendicular. A perpendicular line is the shortest line drawn from a point to another line, okay? We need to find out the equation of the perpendicular bisector because we need to know at what point on the power line should it be connected. So we have to find out this point. Perpendicular bisector, I confused you. It's a perpendicular line, it's not a perpendicular bisector. We're just looking for a perpendicular line that hits this. So it doesn't bisect it, it's just a perpendicular line that's going to be drawn. So we need to know the equation of this line. We also need to know the equation of this line, right? And we're looking for what point they meet. So at what point do these two lines intersect? That's going to be the point where they connect the power line. Find the equation of the black line. Find the slope, find the y-intercept, and then find the equation. Okay, so the slope of the black line is 1/2. Do you want to use coordinate A or B to find the y-intercept? B? Okay. X, y, y equals 1/2 times x plus b. 10 equals 12 divided by 2. 10 take away 6, b equals 4. So the equation of the black line is y equals what? 1/2x plus 4. So the slope of the black line was 1/2. The orange line has to be perpendicular to that. So what is the slope of the orange line going to be? -2/1 or just -2. And what point were you given that's part of the orange line? 619. So we have our m, our x, and our y. Solve for b. Plug in y, m, x. Solve for b. You guys get the y-intercept is 31? Yep. Therefore, what's the equation of the orange line? Good. Okay, so we have our two lines. We need to figure out at what point should the cable wire be connected. Okay, we have to figure out where these two lines intersect. So -2x plus 31 equals 1/2x plus 4. Same thing, solve for x. Solve for x, isolate, x is 10.8. Now we have to find y. Okay, we have to find y. Plug in x. What's y equal to? Y equals 9.4, which means that the cable wire has to be connected at the point what? What was the point of intersection? 10.8, 9.4. So back to the original question, we just found out the point where the cable wire has to be connected. The second part of this question asks you to find out how long should the cable wire be? Length of the cable wire. What formula are you going to use to find the length of this line segment? Distance formula. Okay, so we're finding the distance from, I'm going to call this CD. We need to know the length of that line. Okay, so using the two coordinates, we're going to plug in our values and find the distance. So 10.8 minus 6 squared plus 9.4 minus 19 squared, and you're solving for finding the distance. So D is equal to the square root of 115.2, which equals what? 10.7. Therefore, about 10.7 meters of cable wire is needed because they told us in the original question that each unit represents 1 meter. So if we have 10.7 units, we need 10.7 meters of cable wire.
Made with Doodlecast Pro.